Good day, everyone. Welcome back to BST African Electronic Surgery. It's Monday, so let's fix something. Today we do have a Bluetooth speaker to repair. Let's fix big things, We've been fixing laptops, phones, TVs. What about the Bluetooth speaker? I have this big speaker here. That's very big. I have this speaker. This is the Digmark model DGM-15BT. That's the model of the speaker. The speaker came in as no power. We do have some control things here: bass, volume, treble, echo. Okay, and here we do have an LED which is supposed to turn on when the charger is plugged in. We have the USB port, we have some switches for the LEDs, and then the power on switch. Here we have the AC input. This speaker is working with the one input, the AC input. So what I'll do, I'll take out this cable. This cable is plugged already on power. And let's check the AC input. Check here on the multimeter. 2.19, 2.20. So the AC is okay. The next step. Yeah, this thing is very heavy. Trust me. This is a heavy speaker. Let's plug it here. I can't even hold it. We have the switches here. This one for the power switch, LED switch. And we have nothing. We have nothing on front here. No LEDs. And no charging light. So that's the problem with this speaker. So what can be the problem here? What do you think is the problem? Let's take out the screws. What do you think is the problem of this speaker? Before we open, because I believe this speaker has got a lithium battery inside. If not the power supply, we might have a dead battery. That's what I think. I'm taking out all the screws so that we try to get inside this speaker. So I took out the panel. That's the panel for everything inside that big speaker. These days everything is fake. Look how the speaker it is, how big the speaker it is, and what is inside the speaker. That's all. And what is left on the box is just a one big speaker. So what is here? We drive this board here, which is coming from this is the switching power supply. And what this? Yeah, we have the AC in here, AC in. And here we have the switching power supply. That's the switching power supply. So what did I discover here? I discovered that those pins for live and neutral disconnected here. They're supposed to be here, and they're disconnected. And what do you think about this chip? This is a blown up driver. Because we have AC in, which is being rectified by this small thing. That's a rectifier. It's changing AC to DC. And we have this 400 volts capacitor. That's the big capacitor. This one. And from the capacitor, then this transformer, I think is being switched by this diode. Yeah. This diode is switching this transformer. And we have this driver on the high side. On the high side, we have the high voltage area, then the low voltage area. On the primary stage of the switching power supply. And the driver is blown up. And after the chopper, we have this diode, filter capacitor, and the output. So the problem, we don't have this driver. That is the biggest problem. We don't have this driver, and even if I try to look for board for space, I don't think I'll be able to get this driver. But we have to do some modification here. So from the switching power supply is going to this audio amplifier board. I believe this is the audio amplifier class D. I think so. It should be class D. And we have these two cells to power on the speaker. So what I want to do, let's concentrate on the power supply, because if this radio is not turning on, the problem is coming from here. Because definitely it is coming from here, because the chip just exploded. You can see this chip. The chip just exploded. Maybe you can check this chip. So basically the chip just exploded. That's the chip, which we don't even know what this chip it is. But what I know, this is the driver for the primary stage of a switching power supply. And on the other side, we do have this rectifier. That's the rectifier, the input and the output. And here we do have the capacitor on the output here. That's the capacitor. So what I want to do, I want to check the values of this capacitor. Let's try to fix this. But the question is, how are we going to fix this? Okay. Another problem that we have here, we don't know the output voltage. That is the biggest problem. Is this speaker working? Is this switching power supply outputting 5 volts or 9 volts? But based on the cells, we can conclude the output voltage. Because here, We have two cells connected in parallel mode. These are lithium cells which are working with 3.6 discharge and fully charged around the 4.4 volts. So 5 volts output are capable of charging these cells. Maybe. But there's no voltage written here. VCC ground. What about on the other side? VDD ground. Okay. So let's do some experiment. Let's do some experiment here. I'm thinking to do something dodgy here, just to bring this radio back to life. So what I want to do, let's forget about this switching power supply. And what about using this? This is a switching power supply. This is some kind of charger heads. Huh? What do you think about this? Output 5 volts, 2.4 amps. This is a switching power supply. So let's try to get inside this. How do we get inside this? What do you think about this switching power supply? Would this work? Or nothing is going to work? This is a switching power supply which is outputting 5 volts. So what I would do, we don't necessarily need this USB ports. We don't need these ports. We'll see if this switching power supply can work. If this failed to work, we can look for something bigger. So let's connect this. Let's connect this quickly. We have 2 wires on the output. You know, if you are in this business, try to do whatever you do just to bring the thing to life. There's no best formula. To fix such kind of problems. Minus here. And now let's connect the AC in. And this is metallic. We don't want to cause any short here. So what I will do, I'll try. Let's modify this. Like this. And you sit here. So the question is, do you think this switching power supply is going to work? Let's wait for this glue to dry up and then we'll test the radio. Yeah, now the hot glue has dry up. So the radio is coming on. You can see here, off, on. Let's try to plug in the power. Let's switch it off. Plug in the power. No charging light. Why? The Bluetooth speaker is now turning on, but the problem is it's not charging. I think I know why. we overlook something, so we have to redo the whole process. Here we have this switching power supply, and this switching power supply, this is the primary and the secondary. We have a filter capacitor, and it's saying 16 volts 470 micro. So with the 16 volts output capacitor, we can't put 5 volts there. Logical speaking, 16 volts capacitor cannot output 5 volts. So that is the mistake that we did. So let's go back a little bit. We need to take out this thing. Yeah, sometimes, you know, I'm also making mistakes. Huh? How can a 16 volts capacitor put, or how can you put a 16 volts capacitor on an output which is meant to supply 5 volts? It doesn't make sense. Because mostly if it's in, I found on linear regulators, 7805 linear regulator, when it's outputting 5 volts, there's a 10 volts output capacitor there, not 16. So this is too small to charge the battery. So what do we have here? 12 volts, 2 amps. I think that must be the right thing that we have to deal with. We need something like this. Oh, this is blown up. Why the switching power supplies are dying so easily these days? Huh? Why? We need a proper switching power supply here. Let me look for another one. Let's see this one. I found this one is 12 volts, 2 amps. Let's see this one. Do you think this is going to work? Yeah, this was supposed to be a very short repair. But I blame myself for making such kind of mistakes. The idea of modifying this was right, but the recipe that we did was completely wrong. Because we must have a working speaker coming on and charging. I need some wires here. I need wires. That switching power supply was very small. We hurry up things, but I believe here we're gonna make it this time. So this was a 12 volts output switching power supply, and we come up with 5 volts power supply. I can't believe it's me. I can't believe it's me. But usually I'm not doing such kind of mistakes. Yeah, we're finishing up, and the only thing that is left here is to test. What we want to test, because already we have spent too much time, I'll plug in this connector and see if it's charging. If it's charging, problem solved. On, obvious on is coming on. We are only interested on the charging side. And again, it's not charging. Why? Why is not charging? Is it because 1.5 amps current on the output is too low? Twelve volts, 12.7. So why is it not charging? Yeah, this is now a little bit tricky. Why is not charging with 12 volts? Yeah, this is some kind of tricky repair. So with 5 volts it's coming on, not charging. With 12 volts coming on, not charging. But based on this, or on this audio amplifier board, this board is too small, can't consume more than 2 amps. That is a fact. This board cannot consume more than 2 amps. So I don't want to try with a bigger power supply. So let's check few things here. We have this power supply that we took out from a power pack, which is a 12 volts power pack, which is outputting 12 volts, 1.5 amps. So here we have a filter capacitor. You can see these two capacitors, and the red wire is on the plus, and this black wire is on the minus. So if we try to put on the AC cable here, we don't have any charging light. So that is the problem. Let's disconnect the battery. That is the problem that we have now. I'm 100% sure if you connect all the cables, the speaker will play, but it won't charge. But that can't help the customer. If it is not going to charge, there's no way he is going to use the speaker. So at one point or the other, we have to find out why the speaker is not charging. What I want to do, let's disconnect here. Let's disconnect this panel, the output wires like this. Let's put the multimeter on diode mode. Let's check for short on the output. Do you have any short? Obvious, not on the switching power supply side, but on the audio amplifier board, and it's not shorted. Here we have the USB port here. I'll stick one probe here. Let's test these wires. The black. Check. What Chinese are doing these days? Check, this is the black wire, and it's not going to ground. And the red wire is the one which is going to the ground. Why are they doing such kind of things? Because in electrical or electronic engineering, always use the red wire for the plus, but they do opposite, and we spend a lot of time getting confused. So this red wire, this is the minus, and this black wire, that's the plus. So let's reconnect and test again. That's a stupid design. Why are they doing such kind of things? I don't understand why. So we have a filter capacitor here. The unmarked side, that the plus, so we'll stick the black on the plus. Huh? You see what the Chinese they are doing? They are really confusing us. I never found any circuit with the red wire on the minus. I never found. This is the first time to see such kind of thing, and I was very confused. Maybe we have a shorted power rail or something like that. So now I'm 100% sure if we plug in the AC cable, we must have charging light. And we have this green light, meaning what? Oh, the battery is not plugged in. We disconnect the battery. I don't think these cells are fully charged. We disconnect the battery, so we must have red light there. Check here. We have it's now charging. Huh? You know what? I don't even want to see this speaker, because we spent unnecessary time to bring this thing to life. I can see 37 minutes on the OBS. So let me stick everything together and then we'll do the final test. But the important thing is now charging. This is not my fault, because in electronics or any electrical power engineering, I know the red wire is always the plus, but they put it opposite here. The red is on the minus and the black is, this is manufacturer design fault. It is not my fault. So let me put all together and then we'll do the final test. I've put all together and it's now that time for testing. Oh, that's the speaker. Let me power on the speaker.
Bluetooth mode.
You see? It's working. It's working. Huh? Connected. Let's try to play it with Bluetooth.
We couldn't stop the world from turning. It was like a whirlwind sky. We used to hide under the covers, staring at each other with careless melodies. Something very deep inside us, the major and the minor, were like piano keys. You played for me.
It's working. Huh? You can hear the high sound quality. Everything is working fine. So, yeah, the speaker is on. It's on. You can see from the back. You can see here the LED. And on the charging side, we do have the red light for charging. Even if I turn it off, it's charging. Unplug the AC, plug it back. We have the red light. It's charging. So finally we managed to fix the problem, but we spent too much time because, yeah, I was confused, because generally I know the red wire on the plus. In any electronic bit, radio, speaker, amplifier, any power rail, they always use red wire on the plus. But in this radio, they use the red wire on the minus and the black on the plus. I think that is the designer's fault on this radio. So because of that, we took almost 40 minutes to fix this. But I'm happy I'm happy it's fixed.
Bluetooth mode.
I'm happy it's fixed. So, what can I say? What can I say in this case? Like, subscribe, and don't forget to turn on the notification bell for future updates, and see you on the next one. Bye.